Hello Year 9s and welcome back to Science. This video is going to be explaining to you how batteries work. So the dot point specifically is to explain how dry cell batteries work. Just before I move on, I just wanted to quickly clarify with this question. So in this example, this circuit that I've drawn is in parallel, and we can see that the question asked that you should draw a circuit where you need both switches to be closed in order for the bell to ring. But you can see that in this example that I've drawn, because they're in parallel now, as soon as this switch in particular closes, the bell will already ring because there's already going to be current flowing through this circuit. There won't be any current flowing through here because this switch is still closed, but this already does not fulfill the criteria of the question. So that's why it's really important for this switch to be in the same branch, in the same pathway as the bell. So the two switches and the bell all need to be in series. Okay. Back to batteries. So batteries, they are great. They are light and portable sources of energy, and we've been doing a lot of practice with batteries in class. There's actually a few different types of batteries that exist: wet and dry batteries. So an example of a wet cell battery would be a car battery. An example of a dry cell battery would be a torch battery. But they're both chemical sources of energy. There's also solar cell batteries, but we won't be talking about those this year. Okay, there's a few components that all batteries have, and you need to know these components. All batteries have two electrodes. Now, you're probably thinking, what is an electrode? An electrode is simply a rod, sheet, or plate made up of a metal conductor or anything else that allows electricity to flow through. Okay, so if we have a look at this diagram here, I've got one electrode here, which is a carbon rod. And then I've got another electrode here. It's a little bit hard to see, but just imagine this is a battery cut down the middle, but imagine a zinc casing going around the entire battery. That is the second electrode, because zinc is another type of metal. And interestingly, there's always one positive and one negative electrode, and that just depends on the material that the electrodes are made of. In this case, this carbon rod is a positive electrode, and the zinc casing is a negative electrode. Okay, the other component that all batteries have is an electrolyte. What is an electrolyte? It is a solution or a paste that conducts electricity. So in this example, we've got a dry cell because the electrolyte is a paste. It's not a solution. It's not a liquid. It's a paste. Okay. So what happens is, how the battery actually works is, when you have the two electrodes joined together, so you've got your first electrode here, the carbon positive one, and then your zinc casing around it, there's a chemical reaction at place, and this chemical reaction releases electric charge, so for example, electrons, okay? And then it sends them on their way and allows current to flow through the circuit. So it's all to do with the two electrodes reacting together to release electric charge. Okay, so I said there's two different types of batteries you should know: dry cell and wet cell batteries. Dry cell batteries are found in torch batteries, toy batteries, TV remote control batteries, and all the batteries we've been dealing with in class so far. Okay, so the electrolyte is a paste. That's why it's called dry, because it's not a liquid, it's a paste. And that's good. The positive is, the pros, there's no spillage, there's no liquid to spill. They're lighter and smaller as well. Okay, wet cell batteries, on the other hand, a great example is car batteries. This time, they were called wet cells because they have a liquid electrolyte, which is actually an acid, okay, instead of a paste. That's why they're wet cells. What this means, though, is they are very heavy. I'll show you a picture on the next slide, and they can leak as well. But they can produce a much larger voltage, last a lot longer time, and they're rechargeable as well. Did you know that when you're driving, or when your parents are driving, the car battery is actually recharging itself? All right, and this is a picture of a wet cell diagram. A wet cell battery, a car battery more specifically. We can see that it has a positive electrode, lead oxide, and then it also has a negative electrode, lead, and there's sheets of them alternating. It also has an electrolyte, which is a solution, a liquid this time. Alright guys, And here is a few different diagrams of different batteries. So you can see that they range in size and shape, and also voltage. So the amount of potential energy that the battery can provide. In class, we've been dealing with 1.5 voltage batteries, and we know that if we are to have two batteries side by side like we have in class, we can then increase the voltage by adding up the total voltage. So in class, we've been dealing with 3 volts, but if you were to add a third 1.5 volt battery, then you can combine them all, so 1.5 plus 1.5 plus 1.5, so the total voltage in the circuit would be 4.5. So the point here is each battery has a set voltage, but you can increase the total voltage in the circuit by increasing the number of batteries in the circuit. Okay guys, I want you to switch off this video and jump onto this YouTube video. It's really cool. I got to do it with the girls in class last week, but because we're online now, this is going to be a good substitute. Thank you.